When two parties are using Bitcoin to create transactions and exchange information and payments, they often need to communicate with one another. And the Bitcoin white paper says no mechanism exists to exchange payments over a communications channel. Of course, it then goes on to propose such a mechanism, and we all know that's what Bitcoin is. It's a way for peers to exchange payments peer-to-peer over a communications channel. However, when peers are not able to communicate properly, or when the infrastructure has not yet been built to facilitate such communication, it becomes difficult for people to use Bitcoin properly. And thus we emerge into a world where people try to use chain scanning, indexing systems, tracking systems, and essentially send their payment peer to magic blockchain thing in the sky to indexing service to peer, instead of actually just sending the payment to the recipient, who could then broadcast it to the network. When I write a check, I sign my check to the person, pay to the order of, and then I hand the check to the recipient, who can then take it and register it and effectuate the transfer of funds via their financial institution. However, we have gotten away from that, it seems. When I want to send a Bitcoin transaction to a recipient, the conventional model dictates that I should send that transaction to the miners. In the same parallel, we would be sending the check to the bank when I'm the sender? No. I don't even know what bank the recipient, it doesn't make sense. So, point is, no mechanism exists to make a payment over a communications channel. But what about the communications channel? What about the way the peers are to communicate? Is that not an important thing? If we are to build a network of peers who are exchanging payments directly, do we not require a mechanism to facilitate their communication? Some people don't seem to think so. Of course, judging by their actions, not many have built such systems, and it's been 15 years since the release of Bitcoin, and yet we don't seem to have a reliable and standard way to facilitate peer-to-peer communication. I will give props to things like the SPV channels project, because people in BSV have actually recognized this problem, and we as an ecosystem are currently working out the best solution to it. I think that as time goes on, people are going to find that they're going to want to exchange messages with their peers, and you can do this using several different ways. You can do it using IP to IP, where you have the IP address of the recipient, and you then communicate with them via direct computer-to-computer communication over the internet. And then you have systems like SPV channels, where you can engage with that architecture, and that does provide a solution to the problem, to my understanding. I think that there's room for other solutions, though. That does solve a lot of things, but I think a simpler architecture could sometimes be better. Nothing in this video is to say that you shouldn't use peer channels, SPV channels, because it is a legitimate solution to this problem. However, we have also built a solution here at Babbage, and this is what is the subject of this video. So the problem that is addressed by our solution is You can communicate with people when they are online, of course, IP to IP. You have ways of exchanging messages, but what happens when someone goes offline? You want to guarantee delivery of payment-related messages, and you want to make sure that messages that effectuate the transfer of value are received, acknowledged, communicated properly. And so a message box-based architecture seems to be a reasonable solution. Of course, when I have email, if my device was always online in a perfect world, I would be able to receive email directly whenever it was sent out from a sender, and there would be no need for mail servers. But we don't live in a perfect world. My devices aren't always online, and the point is, the same applies to Bitcoin. When I want to send either a request for a payment or a payment itself or an acknowledgement to a counterparty, I need a way of doing this in a reliable way, and not everyone is always online all the time. Now, there are ways of facilitating always online communications via IPv6, but unfortunately, CGA is far off into the future and not yet as well implemented as I would like. So, PeerServ is a way to facilitate peer-to-peer communications. Every user of the MetaNet, which has a MetaNet client, has the ability to create digital signatures and authenticate their identity. Authorite provides a mutual authentication system between users of the MetaNet. So we have solved authentication at one layer. This isn't the solution, of course, to peer-to-peer exchange of data. If I, as a sender of a payment, for example, wish to send a transaction or wish to exchange some data with a particular user, I need a way of doing so with that user's identity key. And thus, I'm going to compose a message, and I'm going to need somewhere to actually send it to. So traditionally, you would have a single server that you would exchange messages with. You would leave the message and it would be a store and forward service. So when I exchange messages with my counterparties, I'm able to do so on a server. And the counterparty is then able to receive the message and mark it as acknowledged, and then it gets deleted from the server. It's a store and forward system, right? And that's essentially the architecture that we've defined. It's very simple. So PeerServ is a way for users of the MetaNet to contact a message exchange server and send data, and then the data goes into a message box as a message, and then when the recipient comes online, they can check all their messages, receive them, and process payments. So payments can be processed directly between users, and the server merely facilitates the exchange of messages. So with a common PeerServ server, parties are able to exchange messages securely and facilitate peer-to-peer exchange. And the PeerServ integrates packet pay for monetization, meaning that PeerServ operators who run these servers, there doesn't have to be just one for every application, they can make money for the operation of the server. And the clients who interact with these servers, it's actually possible to create systems in the future that facilitate distributed networks, decentralized networks even of PeerServ instances that all interconnect and synchronize messages across hosts. But there is a message. A message goes into a specified message box and is then processed by the recipient. And that's how we can facilitate peer-to-peer exchanges of data. So that's what PeerServ is, and then we have a client library that essentially abstracts away all of the communications channels and things of that nature. That library is called Tokenator because, well, you can exchange tokens, you can exchange payments, you can exchange any number of general purpose messages. And the real power of the system is in its extensibility. You can have derived child subclasses of the implementation that implement higher order functionality on top of PeerServ. So complicated protocols for exchanging messages between multiple parties can be facilitated and orchestrated via this system. And those messages can contain any data, Bitcoin transactions, encrypted data, anything that can be defined in terms of a protocol. And the protocol includes which message box or message boxes to use and defines how senders and recipients of messages are to behave in particular contexts. So PeerServ opens up the communications channel that is discussed by the Bitcoin white paper. And it enables people within the system to exchange data peer-to-peer. So Babbage launches a PeerServ instance for testnet and a PeerServ instance for the Bitcoin mainnet, and will facilitate its operation. We will use Authwrite for user authentication of the people who exchange messages via PeerServ, and we will charge fees for the use of PeerServ instance of our PeerServ instances via the Packet Pay API monetization system, thus enabling users to facilitate the exchange of data among themselves. We will open the specifications used and the protocols used for sending and receiving messages, listing messages, acknowledging messages. And it's very simple. I mean, the architecture is very simple. And other implementations of PeerServ instances can be created. And the creators of those instances can make money by making Babbage not the only person running one of these, as well as providing, charging competitively via Packet Pay. We also think it's valuable to synchronize data among them. So the data structure is a message box and a set of messages in that message box, and then that message eventually gets acknowledged and then deleted on the server. So by synchronizing these, what I mean is that if Alice uses a PeerServ instance that is being run by party X, and Bob uses a PeerServ instance being run by party Y, Alice could send a message to Bob's identity key, and then the PeerServ network would have peering agreements, just like internet networks do, to synchronize and forward that traffic. So that when Bob goes and checks his messages, he'll see the message from Alice. And when Bob responds, that message will find its way back to Alice and where her identity key is, where she talks to. In the future, I mean, it would be possible for people to run their own PeerServ instances and join a network of PeerServ instances. And then you could use things like Confederacy overlays to advertise your PeerServ instance, and that's where your identity key is being hosted, and and coordinate that on top of an overlay, but I think that's a topic for another video because we haven't gotten into Confederacy overlays and how they work on a fundamental level at this point. I hope that this is useful for people building applications on top of Bitcoin so that we can facilitate peer-to-peer exchange. I think that's a reasonably important concept in our ecosystem, and I'd like to see people allocating more time and development effort towards peer-to-peer exchanges of transactions, tokens, etc., rather than systems based on indexing services that must be trusted. Thank you.